In example 3, we're asked to divide this polynomial by 3x minus 4, and in this example, we're going to take a look at dividing using synthetic division when the coefficient of x is not 1. It's 3 in this case. And so there's the division symbol, and we'll put the 6 in this from the 6x cubed, the minus 11 from the minus 11x squared, the 13 from the 13x, and then the minus 7 constant at the end. Now, the restriction here is 3x minus 4, to find the restriction, cannot equal 0. And so I want to solve for x here to find the restriction. So if we add 4 to both sides, then this adds to 0. So we would get 3x is not allowed to equal 4, and then we divide out the 3. So the restriction is x is not allowed to equal 4/3. Notice that it's actually just the opposite of this number, the 4, over this number. And that's because that's the procedure for actually solving a linear equation. So x cannot equal 4/3. So there's a 4/3 over here, and if you're thinking, oh no, fractions, I got to multiply by fractions, it's not that bad here. So the first thing we do is bring that 6 down. Now we have to multiply the 6 by the 4/3, and that's the thing that some people cringe at, but it's not that bad here. So if I take 4/3 and multiply it by 6, now notice that the 3 goes into the 6 twice. So 4 times 2 is what we're left with, which of course is 8. There is a denominator of 1 here, but you don't really need to write it because 8 over 1 is still 8. And so we add the negative 11 to the 8 and get negative 3. So now I need to multiply 4/3 by that negative 3. And the 3 goes into the negative 3, leaving a negative 1. So 4 times negative 1 is negative 4. Adding that to the 13, we get 9. And so one last time, 4/3 times the 9. 3 goes into 9 3 times, and 4 times 3 is 12. And so 12 and negative 7 add to 5. That's a remainder. Now, because we have a 4/3 over here, we didn't actually divide by 3x minus 4. We actually divide by x minus 4/3. That's what we actually divided by. And so the division statement would look like this. Our original polynomial here would equal the product of x minus 4/3, because that's what's over here, and 6x squared minus 3x plus 9. Okay, that's our answer, if you will, plus the remainder of 5. Now we want to know what we get when we divide the original polynomial by 3x minus 4, not by x minus 4/3. And notice that there's a coefficient, a common factor of 3 here. All the coefficients divide by 3. And so I can factor a 3 out of this trinomial. 3 divided into 6x squared goes 2x squared times. 3 divided into negative 3x goes negative x times. And 3 divided into 9, or factored out of 9, gives us a 3 here. Don't forget about the plus 5 in the end. Now this is where we get the 3x minus 4 back from. If you take that 3 and multiply it into the binomial in the front, 3 times x is 3x. And 3 times the 4/3, or negative 4/3, I guess, is negative 4, because the 3's in that product divide out, and we just get negative 4. And then, of course, the 2x squared minus x plus 3 plus the 5. And so that's the division statement now with the 3x minus 4. Now, a little terminology before we leave the dividing part of this lesson. In any division, what you're dividing by is called the divisor. What you're dividing it into is called the dividend, and your answer is called the quotient. And so the division statement looks like this. The dividend is equal to the product of divisor and quotient plus whatever remainder you might have. Now if you take this division statement and divide the whole thing by the divisor, both sides, and of course they divide out here. And then you get the other division statement. Dividend divided by divisor after these divide out equals the quotient plus the remainder over the divisor. So that's where that remainder over divisor part comes from. So there's the two different ways to write the division statement.